So now that we have reviewed what a factor is, now we can go ahead and get into a special set of numbers, which are the prime numbers. And for the prime numbers, we have to remember what factors are, because here are the two rules or the two parts of the definition of a prime number. The first one is that we are using a number that is greater than 1. And then the second rule, or the second part of the definition, is that the only factors are the number 1 and that number itself. So these are the two rules we're looking for. And then see this friendly reminder here, the only factors. Remember, those are the numbers that we multiply to get a certain product that we want. So let's go ahead and take a look at several examples down below. What if, to start off with, we look at the number 2? Well, I know a couple numbers that multiply to be 2. I can take 1 times 2. I could take 2 times 1, but that's the same thing, and there are no other factors of 2. So notice that the factors here, just like the definition said, it said the only factors can be 1, there's that factor, and the number itself. And the number itself is 2, because that matches what we were originally doing. So that matches rule number 1 and rule number 2. 2 is, in fact, a prime number. Let me get rid of this here. 2 is prime. Okay, let's take another example. How about the number 9? Some people think that prime numbers mean that it has to be odd. So let's see if that's true with the number 9. 9 is odd, and so surely it must be prime. Well, I know that for sure 1 times 9 is 9. Those two factors multiply together to be 9. However, isn't it true that 3 times 3 is also 9? So these right here, those follow my rules, but this one right here, 3 times 3, that breaks the rules. Therefore, 9 is not prime. If a number is not prime, we call it composite. But that's just a little bonus vocabulary review. We're really trying to focus on prime numbers here. Okay, what about example 3? Let's take the number 15. So we can't just assume that because it is an odd number, it will be prime. That's not how the rule works. We have to go through each of the factor pairs. Oops, sorry about that. We have to go through each of the factor pairs, and I will go ahead and start with 1, because that's the definition, that 1 and itself are the only factors. Okay, so 1 and 15 do multiply to be 15. They are both factors. 2 does not multiply to get 15. However, 3 does. 3 can be multiplied by 5 to get 15. So unfortunately here again, I do have the factors 1 and 15, but then I have extra factors 3 and 5, and that means that 15 is not prime. It is one of those numbers that we call composite. Okay, just a couple more here just to make sure that we've got the idea solid here. How about we do the number, I forget what I am on. I think I'm on example 4. Let's do 2 numbers in the 20s. Okay. First of all, let's do the number 29. Then let's do the number 27. Okay. So 29, I know that 1 times that number will give me that number. So 1 times 29 is 29. 29 is not divisible by 2 because it's not an even number. It doesn't divide by 3 or 4 or 5 or 6 or 7 or 8 or 9. I can't think of any other numbers, guys, that are factors or multiply to be 29. So the number 1 and the number 29 itself are my only factors. So because it follows the rules, it's a number greater than 1, and only that number itself, 29, and 1 are the factors, 29 is prime. Okay. Then our final example here was 27. I'll go ahead and start with 1. I know that 1 times 27 is 27. They're both factors. I don't think 27 divides by 2 because 27 is not even. But I know that 27 divides by 3. 3 times 9 is 27. And here I had 1 and 27 as the only factors, but as soon as I can find extra factors, that means that that number is not prime. So we found again a composite number. So just as a quick recap of the definition, 2 rules. First, it must be greater than 1. And then second, the only factors will be 1 and that number itself.